Hello, this is Ram. Recording project, recording video for ICP 5. My class ID is 14. So here we have, in this we use sentiment analysis on Twitter data. That's the use case. And in this one we learn basics of LSTM, which is long short-term memory. And then what are the types of RNN, which is recurrent neural networks. And the use case is sentiment analysis on Twitter data, and we have three programs for this. For the first program, we save a model and we use the saved model to predict on the given text data. That is this. Coming to the first problem, uh, this is the first code. I'm running this on Google Collaborator. First, we are importing the required modules, and then we are giving the file sentiment.csv. I had uploaded it in files, and then we are taking only the required data and unnecessary data, and we are using lambda to remove all the unnecessary data from it, and then we are printing the positive and negative size that would be printed on the output. As you can see here, this is a positive and this is a negative. And coming back up, uh, we have now we use tokenize it and print the result, and also run pad sequence on the given data, and then print it again. It is given in the output, and then we create the model, and then we split the given data into train data and test data, and we print it like this shown here. We set the batch size, and then we print the score and accuracy, which can be seen in the output, and then we serialize the model to JSON, and with this code, and then we serialize the weights to HDF5, and then we load the JSON and then create model, and in this code we load the weights in the new model, and then at last we evaluate the loaded model on test data, and at last we vectorize the tweets by prefitted tokenizer instance, and at last we pad the tweet to have exactly the same shape as embedding to input, and we print the sentiment. So this is the output for that. Now this is the first program. Now coming to the second program, we have here. The second program is almost similar to the first program, as you can see from the question. The only thing is we apply grid search CV on the code and then print the results. See, all are same. We use Keras classifier function for the model. We define the approaches, and then we use grid search CV here, and then we print the best of all the approaches and which approach is it using this, and here is the output. As you can see, this is the best. It is 0.844 on approach 2. So this is the output for the second program. Now coming to the third program, we have, as you can see, this is a question. We apply the code on the spam data set available on the source code, and then visualize it using TensorBoard. So it is almost similar to the before one. As you can see here, we are using spam.csv, and then we are tokenizing as before. We are creating the model, and we are splitting the model, splitting it, and then printing the x train.shape and y train.shapes, print x test.shape and y test.shape, and setting the batch size. And as you can see, we are using TensorBoard to visualize it, and we are printing the score and accuracy, which you can see right here. And now opening the TensorBoard link, as you can see, this is the accuracy. It keeps on increasing and the loss keeps on decreasing. Now going to the graph, here we can see this is the graph, main graph for the whole function. So this is ICP 5. Thank you.